this week you have second A group elements and third A group elements. So third A group elements is
In
not
S block element, sir.
third A group element is not complete. This is S block.
Which group element, sir?
S block element in the second A group element.
Okay, sir.
P block element, third A group element. In the
Okay,
third
sir.
element is not complete. Only what is a general property.
So for Saturday's exam, what portions are there, sir?
Second A group element in S block complete.
And third group element?
General properties and anomalous behavior.
And in P block element, sir?
Yeah, P block element only third A group elements.
So these two are there for Saturday's exam, sir?
Yeah, these two and along with last week question, first A group.
Okay, sir. So what about okay, sir. Okay, sir. Fine, sir.
First A group element means that is also belongs to S block.
So for A block element, for third A group element, it is P block element, sir.
A group element is called P block element. That is general properties and anomalous.
Okay, sir. Okay, sir. Thank you, sir.
Next one, I
Sir, 1 minute, sir.
started
1 minute, sir.
the
1 minute, sir. Okay, sir.
yeah. I started chemical properties of so chemical properties of second A group element. In that first I started action with air. Please, you need to respond. Which topic I completed? At least tell me. Action with air, did I completed or not? Hello. Did I complete air action with air? Action with air. MO type of oxides. MO2 type of oxides. Sorry. MO type of oxides will form metal oxides. So I told you B oxide, MgO type of oxide, CaO type of oxide, SRO type of oxide, and barium oxide will form like that. So even MO2 type of peroxides also will form like that, I told you. So peroxides mainly will form barium peroxide will form. Barium peroxide will form. Strontium peroxide will form. And next one is radium peroxide will form. So these two mainly will form peroxides. Told you as basic nature of peroxides. So down the group, basic nature of oxides increases. DeO is less than, MgO is less than, CaO is less than, SRO is less than BaO. So this is amphoteric oxide. This is basic nature of oxide. Is it correct or not? Metal oxides are basic nature of oxides. Down the group, metallic character increases. That's why base of oxide also increases down the group. This is called amphoteric oxide. You know very well what is amphoteric oxide. Amphoteric oxide means it react with both acids and base. That's called amphoteric oxide. Even BeO is covalent nature, MgO is covalent nature. It is insoluble in water. Rest of the oxides are ionic character. It is soluble in water. These points also I told you. Yes or no? Next, action with halogen also I told
So
you.
1 minute before page.
Yesterday I completed all those points.
Thank you, sir.
Yeah. Action with halogen. Action with halogen. And the action with halogen means generally secondary group alkaline earth metals. Alkaline earth metals react with halogen X2. Will form MX2 type of halides will form. What type of halides will form? MX2, BEX2 type of halide, MgX2 type of halide, and CaX2 type of halide, and SRX2 type of halide, BAX2 type of halide, like this type of halide. So case of halogen, I'm going to taking Cl, BeCl2 type of halide, MgCl2 type of halide, CaCl2 type of halide, SrCl2 type of halide, BaCl2 type of halide will form. Down the group, metallic character increases. So BeCl2 is what type of nature? Covalent nature. MgCl2 also covalent nature. Rest of the chlorides are ionic nature. It is insoluble in water, but this is soluble in water. So this is soluble in organic compounds such as alcohol, ether. This is soluble in water. BeCl2, I already told you, there are three types of structure will exhibit it. In vapor phase, it will exhibit dimeric structure. In vapor phase, it is a dimeric structure. Yesterday I told you, dimeric structure. In a solid phase, polymeric structure. Polymeric structure in solid phase. In dimeric structure, sp2 hybridization, planar structure. In polymeric structure, sp3 hybridization, tetrahedral structure. When temperature increases, it is a linear structure, sp hybridization. Is it clear?
Sir,
Yeah, all these points are completed. And action hydrogen also yesterday I completed.
Previously.
Action with hydrogen.
Done, sir.
Yeah, action with hydrogen. I told you action with hydrogen. This one completed or not? With hydrogen, except beryllium. Beryllium, remaining alkaline hexametals. Remaining alkaline hexametals. Hexametals. React with hydrogen. React with hydrogen to form. React with hydrogen to form hydrides. Hydrides. But BH2 is prepared. Then the beryllium chloride react with lithium aluminum hydride. The gives rise to beryllium hydride plus the LiCl plus AlCl3. This is the filtration of the beryllium. But beryllium hydrides when react with hydrogen, it gives rise to hydride. Here is the some chemicals MgG, calcium, beryllium. One type of hydrides form BeH2 type of hydride, MgH2 type of hydride, CaH2 type of hydride, SrH2 type of hydride, BaH2 type of hydride. But in this case, both MgH2 is covalent hydrides, meaning all are alkyl hydrides. Please note this point, ionic hydrides, meaning all are ionic hydrides. These two are covalent hydride. This is called ionic hydride. Ionic hydride. This is covalent hydride. The ionic hydride, otherwise it is called saline hydride. This is calcium hydride, SRH hydride, barium hydride. These are all called saline hydride. Saline hydride. Please note that point. Should I repeat again? Hello. Should I write again?
No, sir.
Chemical reactions.
No need, sir.
Yeah. Beryllium hydride and magnesium hydride. Both are polymeric structure. What type of structure? Polymeric structure. Beryllium hydride and magnesium hydride is a covalent nature. Covalent nature. Rest of the hydride, calcium hydride, strontium hydride, barium hydride, these all are ionic nature. Ionic nature of hydride. This ionic nature is soluble in water. Soluble in water. This is insoluble in water. Insoluble in water. This CH2 is called hydrolith. Hydrolith. So this ionic hydride, otherwise it is called saline hydride. Saline hydride, otherwise it is called salt hydride. Saline hydride, otherwise it is called salt hydride. Is it clear the structures? Beryllium hydride structure. Please listen the beryllium hydride structure. This is the beryllium hydride structure. Beryllium hydride structure. This is beryllium hydride structure. Even MgH2, magnesium hydride structure. This is magnesium hydride structure. This is the magnesium hydride structure. This is the polymeric structure. Polymeric structures. Hope yesterday this one also I completed. Yes. Yes. Clear.
Yes, sir, clear.
Next. After this, please note down from here onwards. You need to note down. React with the diluted acids. React with the diluted acids. Secondary group element react with the diluted acids. Secondary earth metal react with H2SO4 will give rise to metal sulfate. MSO4. Metal sulfate will form plus hydrogen gas will form. Alkaline earth metal react with HCl will give rise to MCl2 plus H2 gas will be created. So sulfate will form metal sulfate and metal chlorides will form. Metal chloride. Metal sulfate means BeSO4, MgSO4, CaSO4, SrSO4. B. Down the group solubility decreases. Please note this point. Solubility decreases. The stability of solid sulfates. Beryllium sulfate is more soluble than compared with radium. Next, after that, going to chlorides. Beryllium chloride, I already told about this one. Calcium, magnesium chloride, calcium chloride, barium chloride, strontium chloride. Down the group as ionic character increases. This is the most important. Halides ionic character down the group increases. its ionic down the group increases. So here you need to remember this is covalent character. Even this one is covalent character. Remaining all are ionic character. These two are insoluble in water. Insoluble in water, but these three is soluble in water. Soluble in water. Is it clear? Over. Completed or not? Next, action with water. React with water. Can I erase this one?
Completed, sir.
Yeah. Now please listen. Next one. React with water. React with water. What type of compounds will form? Generally, alkaline earth metals react with water will give rise to alkaline earth metal react with water will give rise to MOH taken twice type of hydroxides will form. Hydroxides will form plus hydrogen gas will form. But please listen here, beryllium does not react with water. Does not react with water. Because of covalent character this is. Magnesium does not react with cold water, but it react with hot water. Magnesium react with hot water. Hot water. What type of hydroxides will form? Please listen. Calcium react with water will give rise to calcium hydroxide plus H2 gas. This is called slaked lime. This is called slaked lime. Otherwise, it is called calcium hydroxide. Calcium hydroxide. In aqueous medium of calcium hydroxide, in aqueous medium of calcium hydroxide is called milk of lime. Milk of lime. Slaked lime is called milk of lime, otherwise it is called lime water. Aqueous solution of lime water. Milk of lime, otherwise it is called lime water. Please note that point. Please, you have to remember beryllium does not react with water molecule and magnesium does not react with water molecule. But magnesium react with hot water. That means on heating that magnesium will react. Rest of the alkaline earth metals will react with water molecule, will gives rise to corresponding hydroxides plus hydrogen gas will be created. So where calcium hydroxide CaOH taken twice, otherwise it is called a suspension of aqueous solution of lime, milk of lime, otherwise lime water. That's called CaOH taken twice. Please, any doubts? Once you've done, you can inform to me, please. Can I go to next one? Please listen. Next, I'm going to erasing this page. Can I erase?
Yes, sir.
Sir, 1 minute, sir, 1 minute. Yeah, I'm going to erasing this page. Next, what is the basic strength of hydroxide? Basic strength of hydroxide. What is the basic strength of hydroxide? You know what are the types of hydroxides? BeOH taken twice, MgOH taken twice, CaOH taken twice, SrOH taken twice, BaOH taken twice. Hydroxide. Down the group, basic strength, what will happen? Increases. Basic nature of hydroxide increases. BeOH taken twice is amphoteric hydroxide. Amphoteric hydroxide. This is called basic hydroxide. Basic hydroxide. Amphoteric hydroxide, basic hydroxide. This is amphoteric hydroxide, that's why BeOH taken twice react with HCl in the aqueous medium will give rise to BH2O taken 4 times. Sorry, OH taken 4 times. BOH taken 4 times and Cl2. This is called berylate ion. Berylate ion. Even when beryllium hydroxide BeOH taken twice react with OH minus, that means base, will give rise to BeOH taken 4 times. BeOH taken 4 times 2 minus 1. This is also called berylate ion. Berylate. So BeOH taken twice react with both acid as well as base. That's why it's called amphoteric oxide. Even BeO is called amphoteric oxide. Even BeO is called amphoteric oxide. I hope these reactions are clear. Over. Why it is amphoteric hydroxide? Because of BeOH taken twice react with acid will give rise to berylate ion. Even BeOH taken twice react with base will give rise to berylate ion. So that's the reason BeOH taken twice is the amphoteric in nature. Yes, over. Completed. Please listen next one. Next heading, anomalous behavior of beryllium. Can I erase this page?
Yes, sir.
Anomalous behavior. Each and every group first element has some different behavior that is called anomalous behavior. Anomalous behavior of beryllium. Beryllium. What is the anomalous behavior of beryllium? Each and every group in first year group element lithium has some anomalous behavior. Second year group element beryllium has some anomalous behavior. Third year group element boron has some anomalous behavior. 14th group element, fourth year group element carbon has some anomalous behavior. We'll discuss those points. Now, what are the reasons for anomalous behavior? Please listen. So, what are the reasons? Beryllium show anomalous behavior. Anomalous behavior due to small size, non-availability of d electron, non-availability of d electrons or d orbital. That is the reason acting as an anomalous behavior. Rest of the elements having d block. availability of d orbitals, rest of the element, like magnesium, calcium, strontiums, barium. So that's why beryllium shows covalence. Maximum covalency is 4. Maximum covalency is 4. That is the another reason. The rest of the elements covalency is more than 4. Rest of the elements covalency is more than 4. That's why it shows anomalous behavior. And one more point we need to remember here. In the group B2 plus is small size, high polarizing power. Small size, extremely small size, that's why high polarizing power. In the first year, second year group element, which is more polarizing power, BH2 plus is more polarizing power. And you know very well, just now I told you, BeO and BeOH taken twice, both oxide and hydroxide are amphoteric in nature. Amphoteric. Just now I told you this point also. Solubility of sulfate, beryllium sulfate will dissolve in what? Will soluble in what? Rest of the sulfates will not soluble in water. While rest not soluble in water. While rest not soluble in water. So these all are the anomalous behavior of beryllium. Is this clear? These points, these reasons are clear. Please, you need to ask doubts. Otherwise, at least you need to respond. What did you understand?
Completed, sir.
Next, please note down next heading. Diagonal relationship. Diagonal relationship of beryllium with aluminium. So you know very well diagonal relationship of some element, second element and third period element. Lithium, beryllium, boron, carbon. Sodium, magnesium, aluminium, silicon. I already told you lithium has similar property with magnesium. Even beryllium has similar property with aluminum. Boron has similar property with silicon. After this, there is no diagonal relationship. That's why lithium has some similar property with magnesium. Now beryllium has some similar property with aluminum. That's the reason it exhibited the polarizing power of Li plus, sorry, Be2 plus and Al3 plus is similar or similar. Pe2 and Al3 plus is similar. Polarizing power. Polarizing power of beryllium 2 plus and aluminium 3 plus are same. Are similar. That's why beryllium shows diagonal relationship with aluminum. Please, this point is most important. Both beryllium and aluminium are not readily attacked by acids, diluted acids. Please note down diluted acids due to the formation of oxide film. Due to the formation of oxide film on the surface. Oxide film on the surface. That is another reason for exhibiting diagonal relationship with aluminum. Both aluminum and beryllium does not react with attacked by acids due to the formation of oxide film there. This is very important. Please listen. The chlorides of both beryllium and aluminium have Cl minus bridged. Cl minus bridged chloride. Bridged chloride structure in vapor phase. This is the other reason. Both barium chloride and aluminum chloride will give rise to bridged chloride ion. I'm going to write next one.
Completed, sir.
Please write down both the chlorides BeCl2 and AlCl3 both are covalent character. Both are covalent character. BeCl2 and AlCl3 does not dissolve in water. Insoluble in water, but soluble in organic substance. And both BeCl2 and AlCl3 act as Lewis acids, electron deficient molecule. Lewis acids and electron deficient molecules, they are used for Friedel-Crafts catalyst. They are used for Friedel-Crafts catalyst. Is it clear, these points? These all are the reasons for diagonal relationship with aluminum. These are the diagonal relationships of a beryllium with aluminum.
Sir, can you show the previous page?
Yeah, 1 second. I'll please complete this one and show previous one. Can I erase this page? It's over. Completed or not?
Completed, sir.
Yeah. Please note down previous page. Can I start biological importance of magnesium 2 plus and calcium 2 plus?
Yes, sir.
Yeah. So please note down biological importance of magnesium 2 plus and calcium 2 plus. Biological importance. Biological importance of magnesium 2 plus and calcium 2 plus. What are the biological importance of magnesium 2 plus and calcium 2 plus? Any adult body, understood? An adult body containing 25 grams of magnesium and 1200 grams of calcium compared with only 50 grams of iron, 50 grams iron and 0.06 grams of copper. This is adult body containing 25 grams of magnesium, 1200 grams of calcium compared with only 50 grams iron and 0.06 grams of copper. And now I am going to Mg2 plus important biological importance. Mg2 plus ions get concentrated in animal cell. Concentrated in animal cell. Enzymes are involving Mg2 plus. Adenosine triphosphate requires Mg2 plus. Enzymes are involving ADP requires Mg2 plus. And last point about Mg2 plus. Mg2 plus constituent of chlorophyll, the green pigment of plant. Constituent of chlorophyll, the green pigment of plant, the green pigment in the plant. Did you understand? Mg2 plus is the constituent of chlorophyll, the green pigment in plants. Mg2 plus. These 3 points are the biological importance of Mg2 plus. Mg2 plus gets concentrated at one cell. Enzymes are involved in ATP, requires Mg2 plus. Mg2 plus ions is a constituent of chlorophyll, the green pigment in plants. What are the calcium 2 plus important biological importance of calcium 2 plus? What are the biological importance of calcium? Can I write?
Yes, sir.
Please note out biological importance of calcium. Ca2 plus. A daily requirement. Daily requirement of calcium body, human body is about 20 to 300 milligram. Sorry, 200 to 300 milligram. And next, bones, you know very well this point, bones and teeth. Bones and teeth contain Ca2 plus. Ca2 plus. As appetite, you know, bones is made up of Ca2 plus and teeth also made up of Ca2 plus. Appetite. Ca3PO4 taken twice. This is called appetite. C plus. Animal teeth contains fluoroapatite. Please note this point. This is most important. Animal teeth contains fluoroapatite. Fluoroapatite formula 3Ca3PO4 taken twice CaF2. This is called fluoroapatite. Ca2 plus is necessary for blood clotting. Ca2 plus ions, please note down. Ca2 plus ions are necessary for blood clotting. Necessary for blood clotting. Please complete this one. These all are the important. One more is there. Ca2 plus ions necessary for muscle contraction. Contraction. Please complete. This is the important biological importance of Ca2 plus. Did you understand this biological importance of calcium 2 plus? Yes. Hello.
Yes, sir.
One more point you can write. Calcium 2 plus ions are necessary for muscle contraction. This is the important biological importance of calcium 2 plus. Yes, remaining we can continue tomorrow. Is it fine?
Yes, sir.
Thank you, sir.
Thank you. Remaining tomorrow, I'll start 13th group element. That is P block element.
Okay, sir.
Thank you.